Part 1 of section 4.6 is on function composition. So let's get started on this. I think maybe the first thing we need to do here is I need to tell you what function composition is. So I'm going to take two functions. Well, I'm going to try to take two functions. So I'm going to say let f of x and g of x be two functions. The notation f circle g of x means I take f of g of x. Okay, so for example, if f of x is 2x, I know that everyone in this class knows what I mean when I say find f of 1. Right? You plug in 1 for every x that I see in f of x. So I get 2 times 1, which is 2. We're doing almost exactly the same thing here, except instead of plugging in a number everywhere where I see an x, I'm going to plug in a function g of x. So what this notation means is everywhere there is an x in f of x, I'm going to plug in g of x. And on the other hand, I can write g of f of x, which means everywhere there is an x in g of x, I'm going to plug in f of x. And I think this is going to make more sense when we start looking at examples, but before we do that, I have a warning. This notation is not multiplication. Yeah, so just because I have the g next to the f of x does not mean that's multiplication. Also, we need to be really careful because a lot of the time, f of g of x will not necessarily be equal to g of f of x. Okay, so I think I'm done with the warnings here. And let's move on to problem 1. So problem 1 says, let f of x be equal to 3x minus 1, and g of x is going to be equal to 1 minus x squared. We are asked to find g of f of 2. So my strategy with these is the following. I'm going to work on the inside first. So looking at g of f of 2, I'm going to ignore the g for a minute and just find f of 2. I know that f of 2 means I plug in 2 everywhere where I see an x in f of x. So f of 2 is 3 times 2 minus 1, which is 5. Okay, so when I look at g of f of 2, I know what f of 2 is. We just saw that it's 5, right? So g of f of 2 is going to be equal to g of 5. And I know what that means, right? I just plug in a 5 everywhere where I see an x in g of x. And so g of 5 is going to be 1 minus 5 squared. 5 squared is 25. 1 minus 25 is 24. Negative 24. So g of f of 2 is equal to negative 24. Okay, on to the next one. F of g of x. So what I'm going to do is I'm going to take f of x and plug in g of x everywhere where I see an x in f of x. Okay, so here's how I'm going to write this for now. Once you get used to doing this, you don't need to write it out like this, but I'm going to so that we can see what happens. So f of g of x is going to be 3 times g of x minus 1. So what I've done is I've just replaced the x with g of x. And I know what g of x is. It's 1 minus x squared. So this is going to be equal to 3 times 1 minus x squared minus 1. If I distribute this 3, I get 3 minus 3x squared minus 1. So that's 2 minus 3x squared. So f of g of x is going to be equal to 2 minus 3x squared. And I think now is a good time for you to try to find find with a D g of f of x, just for fun. And finally, we have f of x. So I'm just going to plug in f of x where I see an x in f of x. So f of x is going to be 3 times f of x minus 1. And I know f of x is 3x minus 1. So we get 3 times 3x minus 1 minus 1. If I distribute the 3, I get 9x minus 3 minus 1, which is 9x minus 4.